In this video, I'm going to show you how you can combine results obtained with UNet and results obtained with MassCar-CNN. So let's just go back to those two folders. If I go to UNet and datasets, nuclei, I have the individual nuclei I got with the macro. So let's open this image, for example, the second one. And even it's going to be better to open it with annotator, just to see quickly the differences and why it makes sense to try to combine them. So if I go to codes, unit, datasets, nuclei, test, I'm going to open the second one I said, and let's open the segmentation with UNet, second one. So if you look at this, you see time it takes. So we have quite some nuclei. It takes a little bit of time, but it's fine. So what you can see with UNet, let me just adjust a little bit this. So with annotator, you can remove the objects and put them back. What you can see, and it makes a lot of sense, the way we implemented it. Wherever we have signal, we have nuclei. And that makes sense because we obtain an object component based on the background. So everything that is not background is part of a nucleus. So we have nuclei everywhere we should have them. Now, the separation between them looks pretty okay in the stroma and even in the epithelium, not too bad. But it's probably not as accurate as the one we obtained with MassCar-CNN. So let's load segmentation for this particular image obtained with MassCar-CNN. Datasets, nuclei, results, and that's the second one. All right. So here, clearly we are missing some, and we have, so again, hallucinations. So here it's going to be easy to get rid of the hallucination. We are very confident in the areas detected as part of nuclei with UNet. So everything that is detected as nuclei with MassCar-CNN that is not part of nuclei with UNet, it's gonna be removed. Everything else, when you look at the morphology with MassCar-CNN, it looks much more realistic. So we're going to take the results from MassCar-CNN everywhere else. But when we are missing, like this region where we are clearly missing quite a lot, we're going to get the results. Take the results from UNet. So basically, we're going to start with MassCar-CNN. We're going to use UNet first to get rid of the nuclei that don't make any sense. And then we're going to use UNet to add nuclei where we missed areas with MassCar-CNN. And so you don't have to worry, everything is automatic. We have actually a Jupyter notebook. If you go back here, the only one which is called post-processing, and it's combined instance segmentation for combined instance segmentation from MassCar-CNN and the one that comes from UNet. So still the same thing, we start by loading everything we need, and then we have parameters, and here parameters are very simple. Input directory for MassCar-CNN segmentation, input directory for UNet segmentation, and where we want to put them. So I'm going to need to just define one directory. So let me go back here. So let's put it in MassCar-CNN. That's the way I do it, so I just don't want to mess up. You don't have to do it, but I just remember that I do this way. So I'm going to create a folder that I'm going to call combined results, for example. So of course you can call it the way you want. And this is going to be the output directory. So let's go back here. So input directory for MassCar-CNN segmentation. So it's going to be in MassCar-CNN. So here I'm in MassCar-CNN. So I'm going to go into nuclei and results. All right. Directory for UNet segmentation. So here I'm going to have to go up to the UNet. So parent directory, parent directory, parent directory. And I didn't have to do it. I was already good. So codes, unit, datasets, nuclei, individual nuclei. All right. And the output, so I put it in Mascarcian. It's going to be here, and it's going to be combined results. Everything is set up for the parameters. Now I can just run the function. So it's not very long. We can actually look at the pace here, but it takes a little bit of time. So again, I'm gonna speed up the video so you don't have to wait for the entire processing. I'm just gonna wait for the first image to process. You see how much time it takes to process an image. So now I'm gonna speed up the video. All right, it's done. So let's have a look at the results. I'm gonna go back to Fiji, open annotator, and use the same image to see what we get. So if I go to test, I'm gonna take the second one, and I'm gonna load. So where am I? I'm in the right folder, combine result. I'm gonna load the second one. All right, and that's the results we get. So as you can see, we got rid of the ones, the hallucination here in the background. We have nuclei everywhere. And let me adjust a little bit. And so, of course, it's not perfect, but it seems to be, pretty good. If I zoom in the stroma, we have pretty good results, even when we have, problem with DAPI. Clearly, the results we get make quite some sense. In the epithelium, probably not perfect, but again, it makes some sense. So of course we could improve the results by increasing the training data set. We don't have that many images. We have so we used for training 4 images this size, so they're pretty huge. So we are about I would say probably around 30,000 nuclei, so which is already pretty good, but clearly it's not enough. So by combining UNet and Mascarcian, and here we can already improve the accuracy and get something that is probably be interesting and maybe good enough for certain applications, maybe not for all of them. But if you were to get better accuracy, then you need to find strategies. So here, what we clearly see is that UNet converges much faster. So with a low amount of training data set, you're going to get results that are already pretty good. So maybe what you could do in a similar situation is first get the annotation for one image and use this with UNet to get preliminary results, then process a few images and manually correcting, so you can use annotator with that to do that. To increase the size of your training data set, then you can retrain UNet and you can also train Mascarcian with this expanded training data set, combine them to get new results, process a few images and manually correct them, and so on until you reach the accuracy that is high enough for your application.